Ladies and gentlemen, thank you for standing by, and welcome to the Orchestration Server Functionality and Troubleshooting conference call. During the presentation, all participants will be in a listen-only mode. Afterwards, we'll conduct a question-and-answer session. At that time, if you have a question, you can press the 1 followed by the 4 on your telephone, or you can submit a question online using the chat feature on your screen. If any time in the conference you need to reach an operator, press the star followed by the 0. As a reminder, this conference is being recorded Tuesday, October 9th, 2012. I would like to turn the call over to Mr. Jody Draper. Please go right ahead, sir.
Thank you. Hello and welcome to the Orchestration Server Functionality and Troubleshooting Tech Tutorial. I'm Jody Draper, and on chat we have Paul Butler. So today we're going to be covering a few things. Orchestration platform, what is it? Why you would use it? We'll look at some of the supportability questions. We'll take a look at the architecture, the setup and configuration, and then we'll take a look at the logs and some of the common failure scenarios. So orchestration platform, what is it? It's a combination of new and existing applications to enhance routing capabilities. So although we don't like to call it Router 2.0, it is a routing engine that does have enhanced routing capabilities. So there's a few components. The new components are going to be the orchestration server, and that's going to be the routing engine. We're also going to have the composer, and that's going to be the GUI component to design the logic. There's a Cassandra product, and that's going to be for persistence, and we'll talk about that one later. And existing components, just your standard routing components, so your router, your stat server, and your standard framework component. So config server, your T server. So why would you use it? Orchestration Server offers an open standards-based platform, uses SCXML that can accommodate various customer service states. It allows for easier third-party integration. It allows for session management, improved scalability, and it unifies development tools. So right now with IRD and ORS, you're limited to what you can do based off what IRD provides to you. So there's a standard set of functions, and you can't really deviate from those. But with Orchestration Server and SCXML, you have a greater capability to design your workflows and customize your workflows based off of specific service states. Right now, the only kind of integration you get with ORS, you can go to a web service, and you have the ability to go to custom server, but that's tricky. With Orchestration Server, the third-party integration, calling of scripts, is a lot easier out of the box. Right now with ORS, you've got interactions defined really separately. So if you have a web session going on and then you have an email or a chat or a voice call, they're all going to be managed independently and separately. But with Orchestration Server, they're all going to be merged into a single session. So you're going to be able to track from, let's say, a web request to a chat with an agent to an email to a voice, all in one big session. And it just improves session management. Scalability, right now with router, you've got a single router usually. If you want to scale that, you're looking at implementing LDS or having multiple routers and breaking up resources. So it's kind of tricky, and ORS helps with this, and we'll take a look at that. Unified development tools. Right now, GDP8, you're going to be using Composer. And we're moving towards one GUI for everything. So your GDP call flows and your orchestration workflows. GA, which is the the GUI tool now for config layer, that's also going to be used for orchestration. So supportability. Some of the questions that pop up around versions. Right now, Cassandra 1.03. Recommended version, 07X and later are going to be supported. 8.12 ORS and 8.12 ORS are going to be the recommended versions. ORS is currently available on Windows and Linux, and 8.1 framework is a requirement, and that's for the GA side of it. Supported app servers are going to be IIS, JBoss, IBM, Sphere, and Apache. And Tomcat 6.0 comes bundled with Composer, and that's going to be what we use to kind of go through the samples today. There's currently no ORS licenses, but when you get to the point in your logic where you actually have to go and do targeting, your standard URS licenses are still going to apply, your seed licenses. Security is taken care of by TLS between the applications. So ORS is going to have TLS between T-server, interaction server, URS, as well as there's some security between Composer and the config server. Okay, so let's take a look at kind of the different components in the platform and what they do. So the first one, the standard components. These aren't going to change a lot in this new setup. You're still going to have config server. That's still going to provide configuration information both to Composer and to ORS. You're still going to have a T-server. You're still going to have interaction server. They're going to provide the call, interaction, data, and offense to ORS. Right, so that doesn't change a whole lot. And you're still going to have stat server that's sitting there to calculate statistics. So some of the new components in the routing side, at least. So Composer, if you're not familiar with it, it's going to allow you to do drag and drop logic creation. So a lot like IRD. It's going to take that logic and it's going to turn it into SEXML files and save those files off. It's also going to connect to configuration server. So it's going to connect to config. It's going to read all the object information down. It's also going to be able to write to config server. SEXML on the app server. So again, the one we're looking at here is the built-in Tomcat application server. It's going to take that SEXML that Composer generates, and it's going to be able to serve it up to ORS. And that SEXML is the actual logic flow. So when you go through your drag and drop application, you're dropping certain objects down. It's going to turn that into SEXML, and that's going to be your flow. ORS is going to be the logic engine. So this guy is going to receive events from T-server, interaction server. It's going to pull the SEXML from the application server, so it's going to go out and actually fetch those pages. It's going to pull back that data and it's going to execute the logic in that SEXML. It's going to pass target information and functions to URS using the URS functional module. It's going to generate state events based off the events it's getting from T-server and interaction server. It's going to track session information, so the same way T-server tracks con IDs, interaction server tracks interaction IDs, ORS is going to track those sessions. And it's scalable and redundant, and again, we'll take a look at that when we look at the HA side of it. So Cassandra's a newer component in this. It's going to be used to store persistent data, and what I mean by that is while your ORS is going through, it's pulling the SEXML, it's doing the logic, it's going to store that data, so if it actually fails, it's going to go back, be able to retrieve that data, and start off where it left off. Cassandra is also scalable and redundant, same way ORS is. Cassandra is going to use Apache Cassandra NoSQL data store. So it actually doesn't go out connect to an Oracle SQL database. It uses, I guess, an internal one. And the most important thing, it's required in 8.0.118. So earlier versions, you didn't actually need Cassandra to run ORS, but any of the newer versions, you absolutely require it. URS and stat server, so they behave a lot the same way here. URS is still going to be used for target determination. How it gets invoked is just slightly different. ORS is going to pull router in for specific functions, and not just targeting, but some of the other functions that URS is going to have to do for ORS. Statistic calculation is going to be done through URS to stat server, and again, all these things are done with the URS functional module that's built into ORS. So GA is going to be used to provision applications and resources. You could probably compare that to loading strategies in IRD. So you're going to be able to go into GA and provision applications. It's also going to be where you can point to SEXML. So when you design these applications, you've got to point it to an app server somewhere, and that's where you're going to find that. As well, it's going to be what you use to configure all your ORS options. So just like any other standard Genesis application. So the high availability of ORS. The first thing you notice is it does not use primary and backup. So it's actually going to use cluster nodes. So there's going to be a bunch of different orchestration servers working together to act as a single cluster. And they're going to behave as a load sharing as well. So that's where you get your redundancy, and that's where you actually get your scalability. If you get to the point where you need to scale this, the current ORSs can't handle it, you can simply add nodes to that cluster. So a few things to take into consideration when you're looking at the high availability of ORS. All your nodes are going to have the same configuration. So they're all going to connect to the same T-server. They're all going to connect to the same ORS. They're all going to have the same config info. They're all going to connect to the same persistent storage. So all your nodes have to have access to all the same storage. And the way it works is all your super nodes are going to connect. So when you look at the cluster, it's defined, there's 3 different things you can look at. They're going to be your member nodes, your super nodes, and there's going to be a master node. So all your super nodes are going to talk to each other, and that's basically through your configuration in GA. They're going to talk to each other, and then they're going to determine which one needs to be the super node for that cluster. And then that super node is going to be responsible for dealing interactions to each of the member nodes. All member nodes need to maintain a connection to all super nodes. So this is where you need to ensure that all of these applications have pretty good access to each other. You don't want to be kind of distributing these guys where they could potentially have some communication issues. So all your member nodes are always going to talk to all your super nodes. The super nodes are going to determine a master node, and then that master node is going to deal those interactions to each of the member nodes and as well to the super nodes. So even the super nodes and the master nodes can handle interactions. So the Cassandra side of it, it's the same thing. They're going to use a cluster configuration. So you're going to have different Cassandra nodes in your cluster, and it's going to behave the same way. All your ORSs in this case, there's a single one here, but you could have multiple ORSs in a cluster. They're all going to connect to each Cassandra. The Cassandras are all going to talk to each other. And the way this is going to work is the ORS is going to round robin anything it needs to tell the Cassandra servers. So let's say a call comes in, ORS kicks off a session, it starts handling it. The first thing it's going to do is going to go out and get the SEXML, and it's going to write that data to one of the Cassandras. Whatever one it talks to, that Cassandra is going to propagate that data to the other Cassandra servers. ORS is going to keep going. It's going to do some more logic. It's going to get to the point where it has to write something else, and at that point it could write to any one of the Cassandras. If it's a different one, that Cassandra will actually forward the information to the one that was originally dealing with it, and then that original one will propagate the data again. So this ensures that at any point in time, your persistent data is stored in all 3 Cassandras. So if any one of those fails at any time, the other ones are ready to basically continue on from that point. So let's just take a quick look at the overview here. So GA, right, this guy's pretty basic. This is where you're going to configure your DNs, your route points. That information is going to get written to config server. Config server is going to store it. Composer is going to be where you develop your applications. So it's going to read from config server to get all your DN information and your application information. When you build your application, it can write to config server to update that information. When you build the application, you're going to compile it, and you're going to get some SEXML. The application server is going to be set up to go and fetch that or read that SEXML and serve it as web pages. ORS is going to start up, read all the configuration information, determine that it needs to be, if you do have it set up as a cluster, configured to talk to all the other nodes that are defined in that cluster. So if an interaction comes in, and we'll just use a simple call as a sample, a call is going to come into T-server. T-server is going to turn that into an event. It's going to pass it over to ORS. ORS is going to get that event, and it knows what application has to be kicked off. So number one, it's going to go, first it's going to create a session. So it's going to write that information to the Cassandra cluster. The next thing it's going to do is going to go to the application server and ask, okay, well, what do I have to do? What logic do I actually have to execute here? So it goes up to the app server, fetches the page that you've configured in Composer. That data gets returned to ORS. ORS goes through the logic. It gets to the point in the logic where it says, okay, I've got to invoke a target. At that point, ORS is going to pass that information off to URS, and then URS is going to treat that target just like any other, targeting that it would normally do, even if you used a strategy. That server gets invoked the same way. At that point, when a target is actually picked, and that's all done, just like normal in URS, URS is actually going to go out to T-Server and ask for the call to be routed, and T-Server is going to move that call. So that's kind of the overview. That's how the different components fit in together, and that's kind of the flow. So let's take a look at some of the specifics here. So we'll go over setup and configuration. Number one, where do you get this stuff? ORS, pretty straightforward. Just go grab it from the download site. It's going to show up under the Universal Routing product. Composer, same thing. Just go grab it from the downloads. This time it's going to be under its own, product heading, Composer. Cassandra is a little trickier. If you want to get from the download site, you have to go and grab it, the CD. There's not an actual download for it. So you can find it on the Universal Routing CD. The latest version I saw was 81.202.00. There's going to be a third-party applications folder. The problem here is the version that's included is going to be 0.78, and that's a pretty old version, and we wouldn't recommend using that. So instead, we'd recommend you go out and pull that software off of the Cassandra download site directly. At this point, when I went out and grabbed it, this was the link at the time, but I think they might change a little bit. So if they do change, just go to the main page, and then you can go to the downloads. There's an archive, and go grab the 103. I think there's a newer version right now, and I don't think I'd recommend that one at this point because I don't think it's been tested. I think the last one is 103. If you're going to go grab a version, you might want to ask support first, what the latest version supported is at that time. So documentation, there's a pile of different places you can grab documentation for Orchestration Server. We'll just kind of briefly browse through some of them. So the ORS deployment guide, this is going to be where you go if you want to get your overview information, your deployment information, your configuration information for options, and your start and stop procedures. So just like any of the other deployment guides. Composer, same thing. There's the link if you want to go grab it. It's got the overview information, deployment information, configuration, and execution. It's just a GUI, so there's not much on the execution. Again, pretty standard. Release notes, so top one's for Orchestration Server, this one's for Composer, the bottom one's for Composer. If you're not familiar with the release notes, that's probably going to be the first place you want to look if you're doing any kind of troubleshooting. So it's going to give you the latest release information, so what versions are available. It's going to give you the supported operating system list for that version, so it'll tell you if it's available for Windows or Linux. And it also gives you the bug fixes. So if you have a problem and you think it's an older version and you think it might be fixed, check out the release notes. That's probably the first place you want to check. There's a Composer Routing App Users Guide. This is going to have some details on SCXML. It's going to have details on planning your applications and your application development. So when you start getting into Composer and you think, okay, I want to start I want to start building an application in Composer. I want to do some stuff. This is probably what you're going to go and check out to get hints on. Okay, how do I build this application? There's some samples in there, and it gives you some details on kind of planning those applications when you're building them. Composer has a help file. It's actually pretty useful, so it's just a pop-up window. There's going to be lots of stuff in it, overview information, configuration information, a lot of stuff for Composer and Tomcat. There's a little bit about ORS and GA in there, but they're mostly Composer and Tomcat stuff. as well as going to have object definition. So when you're looking at certain functions, when you're dragging and dropping blocks into your workflows, a lot of the times they require parameters. So one of the quick kind of links to get that information is going to be just right in the Composer help file. It also has in the help a cheat sheet. So these are going to be used for if you're trying to do certain, I guess, things. It's a step-by-step list of things you actually have to do. So in this case, it's building a routing application. So where do you start? It actually walks you through the different steps that are required, and it even points out what menu sections you have to hit and what options you have to select. So it's actually pretty useful. And then probably the most, I guess the most information you're going to grab is actually going to be from the wiki. So there's an orchestration developers guide wiki page, and there's the links to it. The top one's just going to be the kind of the root. It's going to be the developers guide. Once you get into that, there's going to be a bunch of different links that you can go to. So the first one, the SCXML language reference. So this is going to have information about SCXML. So we're going to use that spec to I guess, build those files. So there's some details about how SCXML is set up, what the different parameters are for it. IRD to Composer migration guide. This one's going to have certain objects and what they reference to in SCXML or Composer. So if you go into IRD, you've got a bunch of standard functions. They don't map one-to-one in Composer. So sometimes they'll show up as just a normal block. Sometimes they'll show up as parameters under something else, and sometimes they'll show up as unique scripts or subroutines. So this is where you're going to go to say, okay, I've got this block in IRD. I want to know what it looks like in Composer. I want to know how to actually format it to put it in my application. This is going to be the doc you go and grab to figure that out. Migration from IRD. So right now, there's a migration path to take your IRD strategies and get them into Composer. So it's not 100%. The first thing is you export your strategy in XML format and then you import it into Composer. But there are some limitations, and this page goes over some of those limitations. Some of the objects you're going to have to manually go in and do some work on. So this helps with that. And then the orchestration extensions. Again, this is going to cover some of the functions that are available to you, and it's going to detail those functions out. So some third-party documentation you might want to take a peek at. The Cassandra wiki. So this is going to have details on Cassandra configuration. There's details on setting it up as load sharing. Or as a cluster, sorry. I think there's information on setting it up as a service, which I don't think is in our documentation right now. So it's certainly a good thing to go check out. The SCXML spec, so that's the actual specification for SCXML. So we detail it, a bit in that SCXML language reference guide, but the actual spec, you can find it there. ECMA, that's going to be the scripts that we use. It's just basically a Java scripting language, and you can go check out the actual resources there. And JSON, that's going to be a container that we use frequently to pass information between the scripts. So again, pretty useful to know what that's going to look like. So that link's there. Okay, so quick installation walkthrough. We'll go through ORS, Composer, and Cassandra. ORS is pretty standard. There's not much to it. Just like if you've installed the T-Server stat server, same thing. You're going to import the template. You're going to create an application. You're going to run the setup, and literally that's it. The only thing you might get hung up on are some of the options. So let's take a look at those guys. So the first thing you want to do is you want to go in and you want to specify these X-trace options. So if you just specify verbose all and then all to standard out, you probably won't get a lot of information for your troubleshooting. So what you have to do is go in, specify all these X- options, and a value of 3 for all of those seems to get you a pretty good log that you can actually troubleshoot To set up your clusters, there's going to be a cluster section. Name is just going to be the cluster name that this node or this orchestration server is going to be part of. And then supernode option is going to tell it if it's going to act as a supernode or not. So if we remember back to when we were looking at the HA setup, we had a bunch of different nodes. They were either member nodes or supernodes, and this is how it's actually defined. So when, in this case, this guy's called C1. When he starts up, he's going to go read this information and say, okay, what cluster do I belong to if I do belong to a cluster? And then based off that information, he's going to go out and connect to any of the supernodes in that cluster that might be defined. Probably the most important options are going to be the persistent options. So again, the orchestration server 8.0, I think it was 118 plus, have to have Cassandra set up. If Cassandra is not set up, it won't start and it won't continue operating. So the first thing you want to do is set up your Cassandra server and populate these options. So Cassandra listen port is going to be the listening port for your Cassandra servers, and your Cassandra nodes is going to be a comma-separated list of all your actual Cassandra servers. Enabled used to allow you to disable this, so you could kind of bypass persistence altogether and get orchestration server to start up, but it's actually been disabled, so any of the newer versions it's not actually used anymore. There's an option called persistence-default that you can find in the SCXML section, and what this is going to do is actually going to enable the persistence or not. So even though you have to have Cassandra sitting there listening in order for you to start ORS, you don't actually have to use persistence. So you don't have to store the data in the database. But if you do want to, and obviously it's recommended, you have to go and set persistence-default to true. And in that case, it'll connect to Cassandra, and it will actually go and ask Cassandra to write to the database. Connections in ORS, pretty standard. You're just going to have connections to URS, and you're going to have a connection to T-server and your interaction server. The only trick around this one is interaction server. If it's a newer one, if it's type interaction server, so if the actual T-server type or the application type is a type interaction server, ORS has a problem connecting to it, and you have to go in and create a dummy application of type T-server. You give it the same host and port that your real interaction server is listening on, and ORS is going to be able to connect to your interaction server that way. All the cluster and persistence options, or all the setup, it's all option-based. So there's no connections between the different orchestration servers. There's no connections to any of the persistent stuff. So Composer install, again, pretty standard. It's a standalone GUI, so there's no template, there's no application. You literally just run the setup. You'll get a banner, page. You'll get a location where to install it. The only tricky part of the Composer install is you got to make sure you've got a unique port for Tomcat if you're going to use it. You don't want to use an existing port. Memory is a consideration with this one, so not for the install, but when you're actually running it, you want to have a decent amount of memory. 2 gigs probably minimum. So those ones are pretty standard. Cassandra, it's a little bit tougher. So Cassandra, there's no template, there's no application, so you're not going to be doing anything in GA. Again, memory is a consideration. If you have very small amounts of memory, Cassandra's not going to run correctly. For the installation, there's a few things. So prereqs, install. We're going to configure the YAML and load the schema. So we'll actually walk through those things. The prerequisites, pretty straightforward, just Java. Go grab Java, install it, and set your Java_home to whatever your JRE path is. Pretty straightforward. Installing Cassandra is actually pretty easy. So once you've gone out, you've downloaded it, it's literally just an unzip. So there's no actual setup. You're just going to unzip it to that folder, and then you're going to set your Cassandra home to whatever path you got it in. Next thing you're going to do before you actually can even start it is you're going to configure the YAML file. So this is with 1.0.3. If you've got the older version from the CD, the 07X, it's actually going to be a comp file, and it's actually going to be different parameters. So again, with the 103, these are going to be the settings you're going to have to do. First thing is going to be initial token. You're going to have to give a value. Just give it a value of 0. Data file directory, commit log directory, and save cache directory, you're going to have to populate those. They come with look like a kind of a predefined variable, but you want to actually put the path in. The only gotcha here is there's some formatting that goes on. So this is the data file is how it's formatted in the actual file, and you want to keep that. I've had issues where changing the formatting of these files causes some problems, and Cassandra won't start. So seeds is just a list of your Cassandra server. So in this case, it's just a single node. If you're trying to get that running, it's just going to be the server or the IP of the box that Cassandra is going to be running on. Storage port. This one you don't necessarily have to change, but the default is going to be 7,000, and that's I guess it could be a default Genesis application port. So just be careful if you've got anything running on 7,000. Change that. Listen address and RPC address, they come with localhost. You can just remove them for a single node installation. So once you get your YAML file configured with these values, you can go ahead and start Cassandra. So just right in the bin directory, cassandra.bat, you'll get a pop-up, and what you're looking for is listening for thrift clients. So it gives you your port and then your IP. So now Cassandra's running. So we changed the file. We got it up and running. Now we actually have to initialize the database. And to do that, we're going to grab the file called orchestration-schema-sample.txt, and this is actually found in your ORS install directory. So wherever you install ORS, go grab that file, copy it over to the Cassandra/conf folder, and then you have to edit it. So this file is a generic file. It's going to be used for the 07X versions of Cassandra and the 103 versions and the 0.8 versions. So you've got to go and actually modify it for the version you're using. This one is going to be modified for the 103. So the first thing you have to do, you have to go in and rip out the 07X stuff. So in my case, I've got all this stuff highlighted. Just pull it out, delete it. Next thing, you can uncomment, so just delete the comments around the, I guess, the create key space orchestration. So this is actually going to be what is run to initialize the database. So just uncomment it. And then finally, you've got to go in and you've got to remove some of the, I guess, the keys. So for each of the column families, there's going to be keys cached, rows cached, save period. Got to go and remove those if you're using 103. So these were for the older 07X, and the formatting changed on the Cassandra side. So you have to go through each family and remove it. So there's a bunch of different families. There's going to be, in this case, this one is document. But when you look at the file, there's going to be one for session. There's going to be one for session ID, server info. There's a whole bunch of them, including ORS, whatever 111 is the name. So you got to go through each one of those, delete it. So once you have your file edited, and if you follow those steps, you should have a valid file. Then you're going to actually run, there's a Cassandra-cli, and this is actually going to use that file to initialize the database. So in this case, the syntax Cassandra-cli space-host with the IP of the Cassandra server, space-file, and then your actual file you just edited. So when you run that, it actually goes through, it loads your scheme into the actual database, so Cassandra can store that persistent data information. So that's it for the install. Again, the trickiest part is probably the Cassandra side of it. But if you follow those steps, it's actually not too bad. So let's look at a simple sample application. So steps for this are going to be build the application, publish the application. We're going to just check the SCXML and see where you can actually look at that, and then we're going to load the application. So first steps, if you're new to Composer, there's kind of a lot going on in it. It's used, it's not just for this. You can use GVP, and it's actually used for other stuff too. But for the Composer side of it, if you kind of know the steps, it's pretty easy. But if you're not real familiar with it, it's kind of tricky to know what to do. So file new Java Composer project, and this is going to be if we're using the built-in Tomcat. you're going to get a pop-up, and you're just going to give it an application name. If you use route, it's just going to give you your orchestration server, I guess, functions or palette. If you use integrated voice and route, it'll give you the orchestration palette and the GVP palette. It doesn't matter. You can just pick the default and then hit finish. When you do that, you'll get a pop-up screen that looks like this. So on the left-hand side, you're going to have your actual application, all the subfolders. On the right-hand side, you're going to actually have your window. So the first thing you want to do here is you want to make sure you're on the interaction processes, the default interaction process. So we'll call this the IPD. You want to make sure you double-click on this, and it'll bring up that page over on your right-hand side. By default, you're going to have a block in there, and it's going to have some default information. So we're just going to leave that alone, and we're actually going to hit Generate Code. So it's going to take this block and turn this block into SCXML. So the next thing that's going to happen is right here, we're going to get a new folder generated. So now we've got this src-gen folder, and there's going to be this IPD default workflow SCXML. So if we double-click on that, it'll actually pull up the SCXML that was created based off that object. So if we wanted to look at that, you go through this and take a peek. The next step we're going to do, if we go back to that, you can see this workflows default workflow. You're going to open that page, and it's going to be empty to begin with. So the first thing you're going to do is on your palette and your flow control, you're going to drag over an entry block, and you're going to drag over an exit block. And again, we're doing a very basic, simple flow, just to kind of take a peek. So once those are dragged over, the next thing you want to do is you want to connect to configuration server. So up here on the menu, there's a connect to config server button. It's going to give you a pop-up window. You just put in your credentials. You hit OK, and if you're using multi-tenant, you'll get a pop-up to pick what tenant you want to use. So once we do that, we have access to the objects that are in the config server. So what we're going to do is we're going to drag, again on the palette side here, the target. We're going to drag that target over to the block, to the white space. We're going to connect the dots. We're going to click on the target object, and it's going to bring up all the properties of that object. So again, at this point, it's kind of looking like IRD, right? We open up that object. The first thing we're going to do, again, very simple, we're just going to add a timeout. And then we're going to specify a target block. So on the targets, it'll just be a pop-up window. If you click in the field, you'll get a little window that pops up, and you can go through and actually select the agent. So you'll have a drop-down for the type of target, if it's an agent or an agent group, or row point or a skill. Specify the type, and then you'll have another drop-down for the actual resource you want. And that's literally it. So a very simple application that we built with just a simple target. Now we're going to go and we're going to generate the code. And again, that's going to take these blocks and the data behind those blocks and turn it into an SCXML page. So if we go look at that SCXML, we can actually see the target block that we had added and the parameters that were in that target block. So now we've got this SCXML. What we want to be able to do is we want the app server to go grab that SCXML and serve up those pages when ORS requests it. So to do that, there's a few things you got to do. First, you go to Window Preferences. You're going to go to Composer, Tomcat. And again, this is for the built-in Tomcat deployment. Login password, the default is going to be admin, and that's going to give the credentials so that you can actually log in. Next thing you're going to do is go to Project Properties. You'll get a pop-up window, Tomcat Deployment, and then you hit Deploy. And that's going to take those applications that you built, and it's actually going to automatically deploy them in Tomcat, so you can go out and fetch those pages. So we want to make sure it works. So the first thing we're going to do is we're going to go browse to that page. So when we did the install of Composer, we picked a port. Right? So you're going to put the port in there. You're going to go to the host. You're going to go to Status. You'll get a pop-up, again, for credentials, just admin. This time you're going to get another page. You go to List Applications. And now you're going to get a list of all the applications that are being served by that Tomcat. So in this case, we've got Test Application. That's the one we just built. So if you click on that, you'll get a browser pop-up. In this case, it's an error page. But what we want to do is we actually want to tack on to the end of that src-gen/default.scxml. So if we're able to fetch that page and get those details, then we know that the web server is actually passing them. If you can do it from the host, that ORS is running on, then chances are ORS can actually pull that page too. So you want to check the default page, and you probably want to check the IPD as well. So remember, when we were building the application, we actually compiled 2 pages. We compiled the interaction processes, and we built the default page. Okay, next thing we want to do is we want to publish this. So we've got these pages out on a web server somewhere, but they're only in Composer and in the web server. What we want is we want that information to get populated in the configuration layer. So again, we go back to the IPD, right? Make sure that page is up, and then you'll get a new button on your menu called Publish Active Interaction Process Dynamic Config Server. So when we click that, we'll actually take this information and we'll go to Config Server and tell Config Server, okay, I want to add an object in Config Server of type script, and here's the details of it, here's the name, and here's the URL for the pages that it has. And if we go into GA, if we go under provisioning, if we go under routing e-services, and then orchestration, you can actually see the script. So it's a type enhanced routing, and here we can actually see the simple sample application we built, test application. If you double click on that guy and you go under the orchestration section, you can actually get the URL. So if you click on the button here, it's just the browse button. It'll actually pull up the SCXML for that again. So now we want to load the application. So to do that, we're going to go to the DN that we want to load it on. So again, in GA, we browse to the DN. There's going to be an orchestration and routing section. And then the orchestration application, you just hit the browse button, and it'll actually bring up a window where you can pick what application you want to load on that. So this is, I guess, the equivalent of loading a strategy on one of the DNs. The last thing you have to do, so now we've got our application built. We've got SCXML out there ready to be fetched. We've got an application built in the config layer, and orchestration server will know what DN to use and go out and pull those pages. The last thing we have to do is actually tell ORS what to do when a call lands on that route point as well. So for that, we're going to go to that same route point, or that same DN. This time we're going to go to the Options tab. We're going to go to the Annex, and we're going to create a new option called Strategy. And we're going to give it a value of ORS. So if you're kind of familiar with how strategies are actually loaded, it's the same way. When you load a strategy, IRD actually goes out, creates this section under a section with the name of the ORS. So if your router's named, Router Phoenix or something, you're going to have a section called Router Phoenix here, and it's going to be an option called Strategy, and the value is going to be whatever your strategy name is. Now, in this case, if you're using ORS, it's going to be the special name called ORS, and we'll see how it actually handles that later on. So those are the steps. So we build our application. The steps are compile the IPD, create the logic in the workflow, compile the workflow. You're going to publish the application, again, publish the IPD, the workflow. You can check the SCXML just to make sure everything's okay. And you're going to load the application by setting the orchestration application on the DN and by setting the strategy in the ORS section of that DN as well, and setting the value to ORS. So those are the steps. So we've got it installed. We've got it running. We've got a simple sample application built. The next thing we want to do is we want to take a peek at the flow. So we'll take a look at that simple flow. We'll take a look at some of the other functions that you can call, and then we'll take a peek at the logs for some of the failure cases that are pretty common so far, at least. Okay, so here's the flow. The first thing you're going to get some kind of trigger. So in this case, again, it's a very simple flow. The trigger comes into T-Server. T-Server is going to take that and generate a queued event. So here I'm using SIP, so I just get an invite to my T-server. My T-server turns that into an event queued, and it sends it to ORS, and it sends it to URS. In the ORS log, you're going to just see that event like normal. It's going to be a standard TLib event, so event queued receive from. It's going to have all the attributes shown, just like that. Same in URS. URS is going to receive an event queued and print it out, just like normal. In this case, it's SIP, so you're going to get a queued and a route request. So route request is going to be generated. It's going to go to ORS. Then route request is also going to go to URS. And again, in the log, it's going to look the exact same way. So T-server is going to send it. ORS is going to receive it. URS is going to receive it. So now ORS gets this event. It's got to trigger something. So the first thing it does is it goes out and actually creates this session. So in the log, you're going to see the event right here. It's going to have a call UUID. It's going to go out and it's going to check to see if that UUID exists. If it doesn't, the session doesn't exist, it's going to go and try to create a new one. And in the log, you can see that here. So it actually does an IDX add, and it gives you the call UUID, and it gives you the session ID so that you can track on it. So if you're ever kind of trying to troubleshoot the logs and you're looking for session details, you want to grab on that IDX value. So just on IDX gives you all your session information. It shows you when it's trying to see if the sessions exist. It'll show you when you're adding all the sessions, and it'll show you removing the sessions. So it's pretty useful if you're checking for stuck sessions or anything like that. You can do a grep on that, and it'll give you all the created and all the removed. If you're just looking for a list of sessions that were created, then you just do the IDX. And here's the syntax with the add, and it'll give you just a list of all the sessions created during the log files you have, including the call UUIDs. Okay, so ORS got the events. ORS created the session. Now URS is going to do some stuff. So it's going to get the route request, and just like it normally would, it's going to go off and try to kick off a strategy. So in this case, it gets the event route request. It looks for the strategy that's loaded, and the last step in loading that strategy is specifying ORS as the strategy. So it actually picks that up and says, okay, I've got to kick off the strategy. And once it sees that ORS, it actually knows it has to do some special things. So the first thing it's actually going to do is going to go out and create its own session. So now we've got this other kind of SCXML session generated internally in Router. And all it really does is it just kind of sits there. So it suspends that session and starts waiting. So if we compare, we've got now a UUID. We've got an ORS session ID. So here's the UUID. Here's the ORS session ID. And now we've actually got this this URS session ID too. So you have to be kind of careful when you're looking at these IDs. They're all kind of different. You got to make sure you're tracking the right one. And usually you want to be tracking the UUID or the ORS session ID. The next thing to note, and it's not really doing anything functional-wise, but ORS is actually going to update that session ID. So in the logs, by default, you're going to get this request update user data from ORS with the session ID. So again, not really doing anything functional-wise, but it's good to have. In the logs now, if you just have a T-server log or something, you're able to pull from the con ID the actual ORS session ID if you have to go and actually pull those details out of the ORS logs. So that's something you probably want to kind of keep in mind when you're doing troubleshooting. Okay, so ORS has a session created. The URS is kind of waiting for ORS to do something. So the next thing ORS is going to do is it's going to go ahead and fetch the SCXML that it's got to do as far as logic goes. So in the logs, what you're going to see is you're going to see the URL that's supposed to be tied to the script that's loaded on the DN. So remember, we published the application, so we know the name, we know the URL, and we added that application to a certain DN. So now orchestration knows all that stuff. So it knows where to go and at least try to get that page from. So when it goes out and actually tries to get the page, you're going to get this metric doc request, and it's going to give you the session ID, and it's going to give the URL it's going to go and try to fetch. So you're going to get a bunch of other messaging here, SCXML, FM, so that's the functional module for the SCXML. Unfortunately, it doesn't give you the session ID every time, but it's pretty useful if you want to check what other stuff is being fetched. So it's not just those 2 pages that are being pulled, right? It's not just the IPD, and it's not just the default workflow that's being pulled. There's some other stuff that's getting referenced that's also getting pulled. So we can see these common.js, data access JS. So it's actually going out and pulling a bunch of things. When it's all done, what you'll get is this metric doc retrieved. And again, you've got a session ID and the result of it. So if you want to grep on metric doc request, it actually gives you all the applications that you're calling. So if you're doing some testing or if you're looking for a specific application in the log and you don't know what call it is, if you do a grep on metric doc request, it'll return all the applications that are being called, or all the URLs. And from that, you can actually grab the application that's actually going to be called. Okay, so we went out, we fetched our page from the web server. The web server returned a bunch of pages. ORS is now going to take that. It's going to take those pages. It's going to compile them internally, and then it's actually going to do it. Right? The pages are basically logic that it needs to follow. It's going to compile that logic, and it's going to start doing it. So if we go back and remember our very simple sample application, all it was we came into an entry block, we jump into a target block, and then we exit. So in the logs, what we can actually see is, right, doc retrieve, so that's where we get the response back. Result is success, so we know that the pages that came back compiled successfully in orchestration server. Right, so it was able to process those files and put it into something you could understand. And then it starts going through the different blocks. So it starts going through the logic. And again, a very simple application, but it goes through some different states, and then it gets to our entry block. So state enter, entry 1. So now we know we're actually inside that block. And it's going through all the different blocks doing the logic. It gets to a point where it actually enters the target 1. So that was the second block we had. And then it goes into target submit. So now it's inside that block, and it actually has to do something with it. And we know it was a target. We know it was just an agent that needs to be picked. So the next thing we're going to see is invoke function module. So ORS is now going to take that target, and it's going to pass it off to URS. It's going to say, URS, I need you to route this call for me. So in the ORS log, what you're going to see is ORS URS invoke function module. And the method in this case for the target is going to be SCXML submit. It's going to have a call UUID, and it's going to have all your parameters. So when we built that object, we had, we built a timeout of 555, and we put the target information in there. So if you remember earlier on in the flow, URS was, it basically got the events, it got the route request, it kicked off the ORS strategy, it created a session, and it kind of paused, right? It suspended. So URS was in a suspended state, just waiting for ORS to pass it something to do. Now ORS passes that information. URS receives it, so rlib receive from ORS the function SCXML submit with the credentials for that submit. So now ORS is to the point where, okay, it's received instructions from ORS. Now it actually has to do the targeting. So it resumes the session, and then at this point it's just targeting like normal. If you're used to seeing the URS logs, you're going to see the here's targets, and it's just going to be your standard target. So URS is going to go through. It's probably going to talk to stats server to determine, it's going to look at statistics. If it was, group of agents, it's going to make the determination which agent in that group is, ready, which one should get the call, and then it's going to issue the request route call. So it's actually URS issuing the request route call to T-server. So in the log, we can see URS sends to T-server request route call with the target information. T-server is going to process it, so it's going to, in this case, it was zip again, so we're just going to send out an invite. We're going to get an acknowledgement back. When we get that ACK back, T-server is going to generate event route used and event route diverted. It's going to go to ORS, and it's going to go to URS. URS is going to get it. Event route used and diverted. ORS is going to get the same events, right? Event route used and diverted. And then URS is going to answer back to that original invoke. So it's going to answer back with a handle our event. So URS, it's going to get the route used. It's going to decide, okay, routing's done. It's going to check its internal transitions, and it's going to actually send, so our lib request to ORS, this queue submit done. So if we look on the ORS logs, ORS is going to receive the route used. ORS is going to receive the diverted. When it gets those, it's not going to really do anything with them, right? It gets the event processed, interaction on diverted, no transition, so it just kind of sits there. But then a little bit later, it's actually going to get to handle our event. So now URS is coming back to ORS and saying, hey, you know, I got that request and I'm done with it. So now ORS is actually able to process that, right? So it takes that queue submit done, processed, transition selected. So now it's actually going and it's jumping into that last block we had. So state enter, exit 1. Now it's actually going to jump back to the original IPD, and we're going to get into the reach final global exit state, and then the session is going to be rebooted. So that's the, I guess, the very simple flow between ORS and URS. Now, you know, the main logic that you're doing, all of this is going to be in ORS. So when you're going through your different states, that's where you're building it, probably prior to calling URS. Okay, so let's look at some of the other functions that are going to be called from ORS to URS. So some of the common ones, get config option. So here's just a little script in our application in Composer that we built. The Genesis session config, get config, along with an option name. So in the log, it's going to look pretty much the same, right? So up until this point, you're going to get the route request, or you're going to get the queued. You're going to kick off a session. You're going to go out and fetch those pages. You're going to go through all your logic, and then you're going to get to the point where, okay, you've got to invoke URS again. So in that case, invoke functional module. This time it's a different method. It's going to be get config option, and the arguments that are being passed is just the option name. So URS in the log, it looks pretty similar. URS is going to receive that rlib received from ORS, along with the details. So URS is going to treat that the same way as if you had built a strategy with that get config option. So it's going to go through. It's going to specify a value. So in this case, I've got return value as my option value, and it's going to send an answer back to orchestration server. So rlib request to ORS, and result is now return value. In the ORS log, in the ORS log, you're going to get that answer. So message return value. You're going to be able to use that, put it into a variable and use it for the rest of your logic. Another common one is going to be get list. So in this case, again, we have a script built here. We're going through. We're doing a get list with just our parameters. So it's going to look pretty much exactly the same. So ORS is going to send the request, invoke functional module. This time the method is get list item. On the URS side, it's going to behave the exact same way. It's going to get an event route request. It's going to kick off that ORS strategy. It's going to create that internal session. It's going to suspend that session, and then it's going to wait for instruction from ORS in this case. Again, receive request invoke with that function. It's going to turn around, get a value for it, turn around, pass that value back to ORS. In ORS, you can take that value and use it in your logic. Another one is going to be stat server. So in this case, we're actually going to go out and pull a statistic. So we've got our object and our stat that we're going to use. In the logs, I guess first of all, in the STXML, it's actually going to look like this. So Genesis.statistic has data, and then your parameters. In the log file, the first time through, so the first time you hit that, it's actually going to show up as ORS URS subscribe to statistics. So it's a little bit different. You're going to have the statistic and the target in there. URS is going to get that information. So you'll rlib receive from the stat and the object, And then at that point, it's just going to treat it normally, right? Just like it would normally if it had to go and open a statistic. It's going to go into stat server. It's going to create the stat. It's going to reply back to ORS with an acknowledgement with a reference ID, so result of stat subscribe, reference ID 9. And in the ORS log, you're going to be able to track that statistic and those changing values based off that reference ID. So you almost have to know what the reference ID is to track it. But if you do know it, then in the log, you're going to get this ORS URS handle our event, and it's going to have the reference ID, and then message is going to actually have the value. So here I had, I opened the stat, there were 0 calls in queue. I put a call in queue, message 1, so now I've got 1 call in queue. I put another call in queue, message 2, I've got 2 calls in queue. I hung up on one of those calls, now it goes back down to 1. So after that, when you call that statistic in ORS, it's just going to use that value. So it's not going to go back out to URS and actually try to repull the statistic. So in this case, metric, it's going to show you the S data that's getting pulled. And in this case, it's just going to give you the results. So you can put that into a variable and then just use it in your logic. Okay, so those are some of the common functions. Let's look at some of the failure scenarios, some of the common failure scenarios, what they look like in the log files. So the first one, persistence. So again, I mentioned that persistence is required in the ADA 118 version of ORS. So we hit this quite a bit. You try to start up ORS, and it just doesn't start at all. So you go take a look at the logs. At the very end of the log, you see logging service stopped, ORS exiting. So the first thing you want to do if you get something like that, you want to go up and make sure you have your persistence set up. So if you scroll up in the log, you actually get the output of the persistence options. So reading section, persistence, and these are the two you want to take a peek at. So config item, Cassandra listen port, and Cassandra node. So again, those are the values that specify where this orchestration server is going to go out and try to connect to a Cassandra server. If it's not valid, if Cassandra's not listening, or if Cassandra's not initialized, if the database wasn't initialized, you'll get this no Cassandra host available. Orchestration terminating. So that's probably one of the more common reasons you're going to see orchestration stop or not start up, is if you don't have those Cassandras set up correctly. The next thing we see quite a bit is specific to Avaya, but if you've got vector delays on your route points. So if queued and event route request have timing issues. So if we kind of go back to that overflow and break it down a little bit more with Avaya, what you actually get is when a call lands on one of the route points, you're going to get an offered message, and T-Server is going to take that offered and generate a queued event, and it's going to send it out to ORS, and it's going to send it out to URS. And in the actual switch processing or the switch setup, you can specify a delay in there. So you can delay when the call actually starts, when you get the queued, to when you actually generate the event route request or the route message. So you can see in this flow, there's an issue, right? When the queued goes out to ORS, ORS takes that queued and actually starts, right? It starts processing as soon as it sees that queued. So it's going to create the session. It's going to update the session ID. It's going to go and fetch the page, return, right? The SCXML is going to be returned. It's going to compile it, and it's going to start processing it. So it's going to start going through the logic that you've got defined up until a point where, okay, you probably want to do a target. You probably want to pull some kind of function from URS. And if you do all that before you actually get the route, this invoke is going to fail. And the reason is router actually triggers off of event route request. So when the route occurs, event route request gets generated, and only at that point is URS going to go start the strategy and create the internal session based off the call UUID, and at that point suspend the session and wait for something to come in from ORS. So if we kind of look at the logs, what it looks like, you're going to get queued. It's going to be sent to URS and ORS. URS is going to get it, but it's not really going to do anything with it. Right? By default, it just kind of sits there and just waits for an event route request. ORS, on the other hand, it gets it, so it gets the queued. It goes out, it creates a session, right? So it goes to see if there's a session there. If not, it's going to add one. So there's a UID and there's your ORS session ID. It's going to go out and pull the SCXML, so metric doc request, and the URL that it's going to go and actually pull. It's going to go through to the point where, okay, it's got to do something. It goes through all your logic. It's taking different paths, time of day, your custom business logic. It gets to the point where, okay, I've got to invoke URS. I've got to do some targeting. So it pulls that invoke functional module, right, ORS, URS, SCXML submit, so it sends it. Now, URS is going to get that, but the problem is it doesn't match anything. So when it gets this SCXML submit, it stores it for a second, but then it basically just returns an error, so unknown call. And again, the reason is, if we look at the next log, T-Server is going to send out the event route request. So if we look at the timing, we've got queued at 34. We've got event route request at 38, which is 4 seconds later. That route request goes out to URS. URS gets it. ORS gets it, but it doesn't do anything with it. It's already done processing and queued. URS gets it, right? So event route request. It starts that ORS strategy, right? It gives it a session, and it suspends the session, but we're too late. The SCXML submit came in 4 seconds before this. So there's a few things you can do. Number one, if you can get rid of the delay, obviously that's one of the things you can do very easily. Sometimes in the VIA, though, you need that delay. It does some processing on the VIA side, so you might need it. So some easy workarounds are in the ORS logic. Right? The first thing you can do is just, if you know it's going to be a 4-second delay every time, just put in a pause at the start of your logic. Otherwise, you're going to actually have to build into it almost like a suspend for event. So the first thing you want to do is actually suspend for that event route request before you start processing and before you get to the point where you actually have to invoke anything on the URS side. Another failure scenario is if your IPD is not defined. So it's not so common anymore because I guess you actually are clicking on the IPD when we published it to config server. You actually have to go to the IPD. You have to click on it, and then you publish it from there, and it's always going to pass the IPD. But before it was almost like a manual process, and it is configurable, so you can go in and change that URL to whatever you want it to be. But let's say the IPD is not defined, right? So ORS kicks off the session. You get queued. It creates a session. It goes out and tries to process a page, right? So it goes out and actually grabs just default SCXML, right? It doesn't go and grab that IPD first. So the doc comes back, so doc retrieved, and it's successful, right? So it compiles okay. There's nothing wrong with it. And you start going through your logic, right? So you jump to your first block, so in this case, state enter, entry 1. So now you're going through your logic, but it starts, failing. It soon starts failing, and one of the most common things you're going to start seeing is these interaction ID. Interaction ID is not defined. So once you start seeing stuff like that, the first thing you want to do is go back and make sure you've actually published the right SCXML page. Make sure you've published the IPD and not just the default workflow. And how do you check that, right? Where is it defined? So again, it's right on that application. So if we go into, we go to provision, routing e-service, orchestration, and we go to the orchestration section, you can actually see the URL. For the first page, it's going to go out and fetch if you have this application loaded on a VM. And if it's not the IPD, then obviously it's going to fail. And the reason behind that is the IPD does some stuff. Right, it had that default block in there that we compiled, and that default block does a lot of the setup. So it actually goes out, it does all the includes, and it sets a bunch of variables. And the first one you kind of get the error on is that interaction ID. So you got to make sure you have the IPD published. That's the first page you actually go and pull. Another one, kind of an easy one, is if just the SCXML was just not there at all. So in this case, the ORS is initiated. You get the queued event. It goes, creates a session like it normally does. It goes out, tries to fetch a page. Right, so metric doc request. In this case, there's a URL, so that looks good, but it fails. Right, stuff starts coming back as errors, and you're going to look for that SCXML functional module. Right, so connection refused, failed to connect to. And at the very end of it, you're going to get that doc retrieved, so metric doc retrieved, and you'll actually get an error. So we're no longer getting success. Now we're getting a resolved HTTP error. So, standard troubleshooting in that one, you're going to, number one, you got to make sure that, that web server's sitting out on that host, and you can actually serve the pages up, and you can actually get to the page from the ORS box. Just kind of standard troubleshooting. SCXML being corrupt. So in this case, ORS is initiated, you get the queued, it goes, creates a session, it goes, tries to fetch the page, so metric doc request. And this time, the page comes back, so we look for our SCXML functional module, debug level logging, request to, in this case it was the default SCXML, HTTP request completed. So, up until this point it looks good. We're actually getting stuff from the web server, we're pulling back pages. But then when we look at our metric doc retrieved, if we look at the result, we actually get a compile error. So that means that the SCXML that was pulled back from orchestration or from the web application, it's not. There's something wrong with it. So unfortunately, it's not really detailed in the log file, but it does give you a hint, right? So if we look on that next line, we can see default workflow and target one. So at least we know where to start looking, right? We know there's a problem in the SCXML. There was probably some kind of syntax issue, and that's where we want to go to start looking. So if we go just even as a composer, probably a good place to start. Go into Composer, look at that SCXML, and Composer is actually smart enough to give you some details. So right where we saw that problem, right, in the default application, in the target one, Composer is actually smart enough to give you a little hint here, right? So it'll give you a little X, and we know we have to focus on this line. So it's not 100%. It doesn't give you super detailed information, but it gives you enough information to at least start troubleshooting where it is. In this case, it was just an extra bracket on there, and the SCXML was modified by mistake. Force route issue. This one it keeps popping up. So very simple scenario. We've got this application built. We've got a force route block in here, so it's just like the old T route. So all we want to do is we want to force route to destination 6989302. Right? Pretty straightforward. So we put that in there. We compile this application. We load it. Everything's okay. If we look at the events, ORS gets initiated. So if we look at the triggering events, so the event queued, we've got this DN 5009. So this is the route point my application is loaded on. My DNIS, however, is different. So in this case, it was 5000. So my call flow was pretty simple. It came into 5000. 5000 just bounced right over to 5009, and then my application kicked off. So DNIS and this DN are different. So next thing that happens, I'm going to create my session, right? Just like normal. I'm going to do my IDX add. I'm going to pass my UUID. My session ID is going to get created. I'm going to go out and I'm going to fetch my page, so metric doc request, and the URL that I'm going to go fetch. My logic starts, so now I'm jumping through my states, right? Metric state enter. I'm in my entry block 1. So the next block I'm going to do is my force block, so metric state enter. So now I'm in my force block, and while I'm in my force block, I start to see error. So error interaction redirected, and it doesn't like it for whatever reason, right? One of the lines you want to look for in that failure is going to be cannot get link and or device from call. So the reason behind this one is actually that the force route block needs to provide the calling number. So it needs to provide the route point that's actually going to be doing the routing. And in this case, where this DN and DNIS are different, orchestration server doesn't like it. So it's a pretty easy fix. All you need to do is use attribute this queue instead. So in your SCXML, you just go define a variable. You're going to call the function Genesis interactions voice ACDQ, and that's actually going to take this parameter, put it into this variable, and then in our force route block, our from parameter is going to be that variable we defined. So instead of just using DNS, we're going to use that variable. And orchestration server is going to like that a little bit more. Okay, the last scenario we're going to look at, a scenario where a call comes into route point 1. It does a little bit of logic. It moves the call over to route point 2. Route point 2 is going to do some different logic, and then it's going to move the call to an agent. So in this case, my first application, pretty simple. I've got an entry block. I've got a target that's going to go to my route point 2, maybe some post-routing information that does some stuff, and then it's done. In my second application that's loaded on my second route point, I'm going to come in, maybe do a little bit of stuff, and then I'm going to look at a target block. So it seems pretty straightforward. If we look at the logs, though, what we see is ORS is initiated on route point 1, so it kicks off based on that it queued. It uses this UUID and this DN, so we go out, create a session. So add session with this UUID, this orchestration session gets created. The SCXML is requested, so we go out, metric doc request, we go to the web application and try to pull back this SCXML. And it works fine, so metric doc retrieve, that's the next key we're going to look for. Result success, so we know it compiled, everything was okay there. It goes through all the logic, right? So remember, it was pretty straightforward. We went through a few different blocks. State enter, we get into the entry 1. State enter, we get into the target 1, and then to the target submit. So we pass it off to ORS. And the way we pass it off to ORS is that ORS invoke functional module. We do the method SCXML submit with the parameters. So here's my second route point that I'm passing to it. ORS gets that. ORS is going to route the call. So the call is going to be moved to that second route point. Request route call to T-server. So now ORS is going to get that call in that second route point. So it's going to get the queued message. It's going to have the same UUID, but it's going to be on a different DN. So normally what we would expect, all those things we've been looking at over and over. We would expect a session to be created. We would expect that new web page or that new SCXML to be fetched again, and then we expect the logic to be started. But in this case, we don't see anything. We don't see any of that. All we see is this party getting added to that UUID, and then it just kind of sits there and doesn't really do anything. So the reason behind this is, if we remember one of the first slides was ORS is kind of session-based. So ORS is built to handle a bunch of different interactions in one big long session. So the way it was designed is when the call comes into route point 1, it starts some application. And if it goes to route point 2, if it goes to route point 3, or if it goes to an agent, it's supposed to track it on that same session with that same application that whole time. So out of the box, it's not real good at saying, okay, I'm going to break down the session, I'm going to completely end it, I'm going to treat it as a single interaction, and then I'm going to start a brand new one. But you can do it. And the way to achieve that is when you're building your application blocks, when you're building the target, one of the parameters in your target block is going to be this detach property. So if I specify detach property to true, what that will do is it'll take that session and it'll actually break it down. So on my first route point, if I move the call with that target 1 and I have detach set, it will actually break down that session in ORS so that when the call lands on that second route point, it can rebuild a brand new session and then start from scratch again. So those are the common scenarios. There's a few other resources we can take a look at. So courses offered through Genesis University. There's going to be some troubleshooting workshops, T-Server Stat Server and ORS troubleshooting workshop, outbound contact solution troubleshooting workshop. And there's actually, I'm not sure if it's done, but I know they're working on an orchestration server troubleshooting workshop. So instead of an hour and a half, it'd be a multi-day workshop. So for more details, you can go to that page and get the details around that around those classes. Tech support knowledge base, so product advisors, release notes information, product manuals, and white papers. You can get those all on the tech support website. As well, there's a tech support solution search with over 30,000 service request solutions, including some of the ORS ones. And there's weekly notifications of new or updated product advisories and release notes. So you can request that on the tech support website profile. Next tech tutorial that's coming out is going to be the GBP 8 installation configuration. That's going to be on December 6th. You can register for that one, again, on the tech support website. If you'd like to comment on the usefulness of tech tutorials, presenters' knowledge of the subject, future tech tutorial topics, you can send an email to support.webadmin@genesislab.com. So with that, I think I'd thank you for coming, and I guess we can open up the line for any questions.
Certainly. And ladies and gentlemen, if you'd like to register a question, please press the 1 followed by the 4 on your telephone. You'll hear a 3-tone prompt to acknowledge your request. If your question has been answered, you'd like to draw your registration, you press the 1 followed by the 3. Using a speakerphone, please lift your handset for entering your request. And once again, ladies and gentlemen, for any questions or comments through the phones, it is the 1 followed by the 4 to register your question. Also, you can submit a question online using the chat feature on your screen. And ladies and gentlemen, once again, as a reminder to register for any questions or comments through the phones, you can do so by pressing the 1 followed by the 4 on your telephone keypad. Or if you like, you can submit a question online using the chat feature on your screen. And Mr. Draper, we do have a few questions queued up through the phones. First question from the line of Bill Boga. Just go right ahead with your question. Mr. Boga, your line's open for your question.
All right, thank you. If you're running the orchestration server, can you still have traditional strategies loaded in router against the route points, or do you have to have a separate instance of URS?
Yeah, you can. So you're talking about on a different route point probably, or different resources, right?
Yeah, of course, right.
Yeah. So if you, yeah, you can definitely have, URS controlling certain resources by, just specifying the strategy that you set, just like normal. So instead of having that ORS strategy, you would just have your normal strategy built.
And it's the same. You can have a single instance of router, because when I was at a GeForce in Seattle, the class had it as you had to have one router that was working with orchestration server and a separate instance of URS that was used for traditional strategies. So that's not the case?
No, it shouldn't be, no.
Okay.
So I think you actually have to go and specify the ORS strategy on each individual resource, and I think it's actually for that reason. I don't think it's a global option, so you can pick and choose. At least I don't know of any technical reason why you can't do that.
Thank you very much. And ladies and gentlemen, once again, if you'd like to submit any questions or comments through the phone, it is the 1 followed by the 4. Or you can submit a question online using the chat feature on your screen. And our next question is from the line of Lee Grisham. Go right ahead with the question.
Hi, Jody. It's Lee. I think you mentioned that ECMA scripts were JavaScript. So I'm assuming that implies that ORS and the application server are able to read and compile both SCXML as well as JavaScript. Are there other languages that can be used?
To be honest, I'm not real sure. I'd probably have to take that one away and do some digging on it.
Is JavaScript, in fact, being compiled and rendered?
Well, it's not actually. I don't think it is actually JavaScript. So it's ECMA scripting, which is slightly different.
Okay. Thanks.
Thank you very much. I will proceed with our next phone question, the line of Mike Dorn. Just go ahead with your question.
Yeah, hi. I had a question on fetching of the SC XML pages. I know also at GeForce in that class, there was some talk about delay and the fact that each call fetches a page. Is that still the case, or does it cache any of that information if nothing's been changed in the actual XML?
You know what? Again, I'd have to take that one back and look at it. I know there is some caching that shows up in the log. I just don't know the extent of that and what you actually have to do to get it enabled, and I guess how much right now is developed around that.
Okay. And I know it showed in your logs that it was about 300 or 400 milliseconds, but I think at the GeForce there was some concern because there was a comment that it could take potentially up to 2 seconds to fetch that page and start running it. And I guess that's just going to be based on your web server and in relation to, yeah.
Yeah, I'd be surprised if there wasn't. I would say, probably open up an SR and we can go through and figure out exactly how you set up the caching on that. I don't want to say 100% there is, but I know when I've been looking through it, I've seen kind of hints to that. In the log, it actually says if it's cached or not, but I've actually never gone through and did any digging into it.
And if there is a long delay in fetching the page, I'm guessing it, much like now, if it can't load the strategy or run the strategy, if there's an issue in the strategy, it just default routes after it.
Yeah, I mean, eventually, right? If you're whatever is doing that trigger on that, usually it's set up to wait, a decent amount of time. But yeah, if it really is long enough, then sure, you would eventually default it. Okay.
Thank you very much. And Mr. Draper, we have no further questions through the phone, so let's proceed to check if there are any online questions. And as we're waiting, ladies and gentlemen, once again, if you'd like to register any questions, comments through the phones, there's the 1 followed by the 4 on your telephone keypad. Or you can submit a question online using the chat feature on your screen. And Mr. Draper, do we have another follow-up question on the line of Mike Duran? Go right ahead.
Yeah, I did have one other question. You had mentioned that obviously orchestration server starts with an event queued, and there's some things you can do around that. Is there any plans for URS to create the session ID in the future on an event queued versus on an event route request to solve that issue?
I don't think so. So we've actually gone through that a bunch of times, and as far as I know, there's been really nothing that's come out of that to say, okay, we're going to change how that works. Because yeah, we have been through that a number of times, and it's been brought up, and I've never seen anything come out of that, unfortunately.
Okay. And then one other question about the stats. You had mentioned it fetches the stat once, and then uses that value. Does it go back to stat server at any default time to update that information, or is that configurable?
No. So once the statistic is created, stat server is going to keep tracking it. So if you're asking if there's like any kind of time period where it will get closed or anything like that, no.
Well, I guess more of what I was asking is, does it go back to stat server each time to get an update?
No. So it's almost going to be a push, right? So when you go out and you actually request to open the stat, it's going to open. Open the stat, and stat server is going to push that value out every time. So
Understood.
When it's changing.
And is there any insensitivity or time configurations on that?
I'd have to double check.
Okay.
So regarding like time profiles and all that, I'd have to double check. I don't know right now.
Okay.
Thank you very much. And Mr. Draper, we have no further questions through the phone lines. Please continue with the presentation or any closing remarks.
I think that's all I had. So thanks for coming, and I guess thanks again.
Thank you very much. Ladies and gentlemen, this does conclude the conference call for today. We thank you for your participation. I ask you to disconnect your lines. Have a great day, everyone.